key idea about Practice 8 is that mathematics lends itself to making generalizations. In this video, students are given the opportunity to work with rectangular solids, to work with and express regularity in a pattern.
Okay, so Marielle's group said to multiply the length times the width times the height. Okay, so can you describe your strategy again and why you think it works?
When it says like the length, you would multiply 5 times 4, and then you would multiply the height, which would be 3, and then you would get your answer.
The teacher pushes the student to go deeper with the mathematics by pushing them to represent their thinking in a variety of ways. This includes models, symbols, and with words.
But I have another student repeat Marielle's idea. And also, could you tell me if you agree or disagree if that would work or not? Go ahead, Sarai.
I agree with this strategy because she said that you have to multiply the length times the width times the height. And we tried that with, because we made 2 different rectangular prisms and it worked for both of them.
It worked for both of them to do that when you multiplied the length times the width times the height? Okay, great.
As a result, students come up with what many of us call a shortcut, or a standard method of calculating volume time and time again. The wonderful part is that students are now examining other ways to look for other patterns and coming up with more and more shortcuts.
Are strategies number 4 and strategy number 3 almost the same thing, really? What do you think about that? Cedric?
Yes, because it's number 3, it's kind of just doing it just a little bit faster, because number 4 you have to split them into layers, and then you still are going to get the right answer, the same answer, but for number 3 you'd have to multiply the length, the width, and the height. So it's kind of like doing the same thing, just you take away one step.
So at the root of what Practice 8 is helping students come up with these generalizations or patterns, or what many of us call shortcuts, but they're rooted in conceptual understanding and not just a random fact or a random formula, but they really understand what that formula or shortcut is representing and trying to solve.